Hi dear students, so today we will discuss the last part of laws of motion, that is gravitation. Simple thing, whenever we have discussed about gravitation, the one diagram that has come to our mind, that this is a tree, okay, and from the tree the apple has fallen, okay, and Newton is sitting there. Definitely I cannot able to draw Newton. The apple is fallen downward from a tree, and by that one idea has striking on the mind of scientist Newton, that there is gravitation. You might be thinking that before it is shown by Newton, previously the apples are going upward. No, the apples are falling downward from the birth of the earth, okay, and from the birth of the apple tree also. And the scientists apart from Newton, they have shown this property, and they just try to justify it in different way. But the way which is approached by the great scientist Newton, that is most scientific, and that's why we have taken that Newton has discovered the law of gravitation scientifically. Earlier also the people have shown, people have make research with it, but their approach was not proper. But that things we shouldn't forget, that before Newton also many great scientists are there, they are trying to finding the cause of it. Okay, now we are coming, what is gravitation? Gravitation is nothing but the attraction between any two bodies in universe. In this universe, any two bodies are attracting each other. Any two bodies. So we can, whenever we are talking about universe, we are very much serious about that. Universe means whole universe, not a simple earth, moon, Jupiter or something. We have taken all the things. So everywhere there is an attraction force between them, and that attraction force is gravitation, and the name of the force is gravitational force. Now, earlier people don't know on which thing this gravitation depends. Many people have tried, but Newton has shown us that this gravitational force, whatever we are talking about, this gravitational force between two bodies, number one, it is directly proportional to the product of masses of them. What we have written, that this attraction force depending on the product of the masses of the two bodies. If I am talking about one body, it is here, and another body, it is here. Its mass is m1, its mass is m2. The attraction force between these two body depends on the product of their masses, that is A proportional to m1 into m2. And here one thing we have to mention, that when the distance between them is constant, means, now whatever the distance are there, if it is r, if the distance is constant, then the force is directly proportional to product of masses. What it signifies? It signifies that if you have taken heavy bodies then the attraction will be more. If you have taken less heavy body, then the attraction will be less. That means, as I have told, that attraction between any two bodies, now I am making you clear, any two bodies means whatever the bodies will be. The body will be any two. The body can be sun and earth, or sun and moon, sun and Jupiter, the celestial bodies. The body can be anything. If I'm talking about two mans or two men, I'm sorry, two men, the body can be the subatomic particles like proton, neutron. Okay, so any two bodies means any two body, and the force of attraction depending on their masses. So it is clear, as the mass of sun and earth is more, so their force of attraction will be more. If I'm talking about the force of attraction between two men, so there it will be lesser. And for proton and neutron, we know their mass is very less, so for them the gravitational force is negligible. Keep one thing in mind, the force is negligible, but it is. The gravitational force is sustained between any two bodies. Next law, number 2. It is told that this gravitational force between two bodies inversely proportional to inversely proportional to the square of distance between two bodies. Means that this force is inversely proportional to the square of distance. And here also one thing we have to mention, that mass or masses should be constant. Now many things I have written, I'm just stopping here and just want to explain step by step. As I have told, the two bodies are kept at a distance of r. So here it is told that this force of attraction, that is the gravitational force, is inversely proportional to the square of the distance. That means if you increase the distance, then the force will decrease. Inversely proportional means if you increase that quantity, then the force will decrease. Okay, and here we have to mention that if it is same for two masses, that masses remain constant, that is m1 and m2, but if you increase the distance, the force between them will decrease. If you decrease the distance, the force between them will increase. Okay, simple thing. Whenever we are talking about the solar system, the planet which is nearer to the sun, on that planet the force of attraction by sun, it is more. Rather, if I have gone to the last most planet, there the force of attraction will be less. So more the distance, less the gravitational force. So the property of the gravitational force we have seen. Now this one we want to show it in a numerical form. Okay, so when we have written it together, okay, that is whenever we have to write down it together, that is F is proportional to m1 into m2 by r square. When m1, m2 and r, everything's are changed. Okay, when everything's are not changed, actually varied, it is the appropriate word. Okay, so when everything is varied, then the property will be shown by this way. Okay, and now if I want to make it an equation, we know from proportionality sign to equation, whenever we have to come, we have to give a constant, and here the constant we have taken, that is g, m2 by r square. So this g Definitely, what is it? It is a proportionality constant. Proportionality constant means which constant we have used to make a equation, but it is not a name. So for G, there is another name, right? Because it is another constant, so you have to give a name to it. So that name is universal gravitational constant, and its value we have to discuss little later. But this is the equation F equals to G m1 m2 by r squared, and it is known as Newton's law of gravitation. So till now, whatever the things we have discussed about the gravitational force, that is done by Newton only, and that law, what two laws we have seen, that force is directly proportional to the product of masses and it is inversely proportional to the square of the distances, and by that what equation we have formed to find what is the target. We just want to find the force of attraction between any two bodies. That equation or that derivation is done by scientist Newton, and that's why this law is known as Newton's law of gravitation. Okay, I think this portion is clear. Now we will little discuss about this G. It's a very interesting thing. What? Now we have told its name is universal gravitational constant. Now you might be thinking, sir, gravitational constant is okay, but why it is universal? It is universal because what you are thinking, it is right, that the value of G doesn't change with time, space, and medium, and for different bodies also. That's why it is universal. Means if you have taken the value of G in any place, it will be same. It cannot be changed. It will be constant. And that's why this value is known as universal gravitational constant. Universal gravitational constant, this certifies that it is same in whole universe, in any point and between any two bodies. When we are talking about the force of attraction between sun and earth, earth and moon, in this case also whatever the value of G, it will be same if I find the gravitational force between neutron and proton also. It doesn't, it remains same for different bodies also. That's why it is universal. Okay, what is the value of it? G. So its value is 6.67 into 10 to the power minus 11 Newton meter square into kg to the power minus 2. This is the value of G, whatever I have told, that it is remains same for any place what we are talking about and for any bodies. Now from where the values have come, it has come by an experiment that is known as Millikan oil drop experiment, and that is not in your syllabus. Okay, whenever you will be in class 11, then you might be know that thing. Okay, that time also it is not in your syllabus. If you are interested, you can see by in Google that what is Millikan oil drop experiment and from where the value of G has come, you can see it. Okay, but for your syllabus it is not important, and I don't want to go there because then it will be little boring also. Now the question has come, why you have given this unit, from where the unit has come? It is very easy. As the equation we have written, F equals to G m1 m2 by r square. So from here we can write g equals to f r squared by m1 into m2. Very easy. And here you see f means what should be its SI unit then? Now for F it is Newton, for R square it is meter square, and m1 into m2 means these are masses, so kg square, and that will be Newton meter square kg to the power minus 2. So from here the unit of G has come. So as the unit has come, then we might be going for define this thing also. We just want to define the constant. So for defining it, what we have to use? Now we have to assume that if R, if M1 equals to M2 equals to 1 kg and R equals to 1 meter. See, in the equation, m1 into m2 equals to 1 kg and r equals to 1 meter. If we have put there, you see, so F equals to g into 1 into 1 by 1 square as per this equation. So here we can write F equals to g, and by this we can able to define the value of G or the definition of G. What should be the definition? Now, universal gravitational constant is a force of attraction between two bodies of mass 1 kg and they are kept at a distance of 1 meter. That means simply when we have taken two masses of 1 kg and when they have kept at a distance of 1 meter, then the force of attraction between them, that will be equal to universal gravitational constant, that is G. So by this way we can able to define G. So definition of G, that is also in book, just read it and then the whole thing it will be completed. Okay, so up to universal gravitational constant it is clear. Now, I'm just telling you one more interesting thing. Universal gravitational constant, if it is clear, then I'm just telling you one small interesting thing. What is that? Just now we have told that when we are talking about two bodies, this is body number 1, this is a body number 2. Its mass is m1, its mass is m2, and they are kept at a distance of r. Okay, so if I am finding out force of attraction, then it will be G m1 into m2 by r square, that we have done just now. Now, if I am asking you that it is the total force, I understood, but force applied by body 1 on body 2. So two bodies are there, 1 and 2. I am asking that force applied by body 1 on body 2. This force is denoted by F21. So F21 means force applied on 2 due to 1. Okay, so how much force is applied? That is F21. In which direction it will be acting? Now, as it is an attraction force, so F21 means this attraction force means 1. It is trying to attract M2 in its direction. That is F21. What will be the value of it? Whenever we are talking about the value, then it should be same with the gravitational force, that is G m1 m2 by r square. Now you might be asking, then sir, force applied by body 2 on body 1, So body 2, it is also applying a force. How much? That force should be F12. Force on 1 due to 2. That's why we have written 1 2 or 2 1. So that force should be applied by 2 on 1. So it is F12 and it will be attracting towards 2. Okay. Then what will be the value of this? Then also we have told the value will be this F. That means from here I just want to explain you that the force between them, what we have calculated, that force will be same for each body to another body. For each body to another body, they are applying the same amount of force. Means how much force I am applying to another body, that much force also applying the another body with the same. Okay, but you see the direction, it is not same. You see the direction is different, F21 and F12. So the direction is same. So we can write here as the magnitude of two forces are same but opposite, then it can be written as how much? That F21 is equals to F12, exactly same but opposite, minus. Now by seeing this calculation, you might be thinking that this type of calculation we have seen in Newton's third law of motion. Yes, it is nothing but Newton's third law of motion. So we can mention there it is nothing but Newton's third law of motion. So from here we can conclude that Newton's gravitational law obeys, because Newton gravitational law is dealing with the forces, it should obey Newton's third law of motion. So any place where we have to dealing with force, we should obey Newton's third law of motion. Without Newton's third law of motion, the effect of force is not shown. Okay, so for that reason I have shown this thing to you. Okay, then you might be thinking, sir, that means when I am standing here and nearer to me my friend is standing, so there is an attraction force between us, then it may possible that he is just coming from there and stick with me. When I am going by the road, another person is coming here nearer to me, then they might be just stick together. These two pen I have kept at a distance, so if I release they will stick each other. So it is not happened. So you have told there is a force of attraction between any two bodies, but I have not seen the force of attraction due to gravitation around us. That means Newton wrong. No, my dear, Newton is not wrong. Then what thing is wrong here? Okay, let's see. When we are talking about two persons, so let's find out force of attraction between two persons. Assume whenever I'm talking about a person and asking his mass or her mass, whatever the mass may be, generally we have seen around ourselves 50, 60, 70, 80, just like that. But if I'm taking little heavier than me also, then we can take the masses M1, okay, it's 100 kg, okay. little heavier person. So I am taking two person, both are having mass 100 kg. Okay, I'm just taking, and they are standing at a distance of 1 meter. And now we just want to find the force of attraction between them. Let's see. So F equals to G m1 m2 by r square. Value of G we all know, 6.67 into 10 to the power minus 11. M1 m2 means 100 into 100 by 1 square. Now you see 100 into 100 means 10 to the power 4, right? So we can write here 10 to the power 4. So 10 to the power 4 and 10 to the power 11. So it is 6.67 into 10 to the power minus 7. That much of Newton. By seeing the value, you see 10 to the power minus 7. This is the order. And 10 to the power minus 7, it is not me to tell you that this is very less. So whenever we are standing, we are sitting, we are going, there is a gravitational force attracting between ourselves, the objects around ourselves, but this force is so small that we cannot even feel it. Okay, but if the two bodies we have taken, that one is earth and another one is moon, then you see, let we are talking about force of attraction between earth and moon. So we need to learn the mass of earth. So the mass of earth, it is around 6 into 10 to the power 24 kg, and mass of moon, it is around 7 into 10 to the power 22 kg. And if I am talking about their distance, it is 3.80 into 10 to the power 8 meter. Okay, it is not that you have to remember. I have done it for a long time, that's why I can make remember. And this is also not accurate. It is 7 point something, it is 5.9 or something. So we are taking it to show you the order mainly. Here it is 10 to the power minus 7. So definitely the force is very less. But whenever we are talking about the celestial bodies, what force is coming? Let's see. G m1 m2 by r square. So 6.67 into 10 to the power minus 11. Mass of earth. Okay, so here m1 m2, it is not right. So we have to write me, that is mass of earth, and mass of moon. Okay, so mass of earth, it is 6 into 10 to the power 24 into 7 into 10 to the power 22 by r square means 3.8 into 10 to the power 8 whole square. Okay, so that should be the force between them. Now what we have to do? Now we have to take the power term in one side and non-power term in another side. So let's see, 6.67 into 6 into 7 by 3.8 whole square. So these are non-power term we have taken into one side. In another side, you see 10 to the power minus 11 into 10 to the power 24 into 10 to the power 22. Then this 10 to the power 8 whole square, that should be 10 to the power 16. If you're taking up, it is 10 to the power minus 16. Okay, and now we know for multiplication the power should be added or subtracted. So minus and minus, minus 11 minus 16. So together it will be 10 to the power 27. Okay, so directly I can erase this one, and here we have to write, it should be 10 to the power minus 27. All the minus power we have to add it, and 24 and 22, so it will be 46 it is 10 to the power plus 46, and here also if you calculate it will come 19. So we erase it, it will come 10 to the power 19. This much of Newton. Now you see, no need to tell for me that this 10 to the power 19 means it is huge rather than 10 to the power minus 7. Okay, so that's why for celestial bodies the gravitational force can be felt very easily, but rather whenever we are talking about any two bodies, then we cannot able to feel it because it is too lesser. Okay, and here this calculation whatever we have made, it is not important for us. Okay, because the order is 10 to the power 19 and it tells the whole story that it is very large. Okay, so that is the comparison between the force of celestial bodies and the bodies, whatever the general bodies we have seen around ourselves. Now the question has come that what will be the characteristics of this force, because as we have discussed so many things, so from here we will get some characteristics of force. What is it? The characteristics, if we are talking about the first characteristics of this force, it tells us that it is a force of attraction. Here there is no chance of repulsion. It only depends on the masses of the body and along with the distance between them, and the force is solely a attraction force. Number two, that is also very common, that we have just seen in the law, that it is directly proportional to the product of masses. Product of masses. Okay, and here number three, it is inversely proportional to the square of distance. And number four, that we have just seen, that is it is significant for celestial bodies. So it is significant for celestial bodies. If we have taken the body having smaller mass, then it is not significant. So for getting exact gravitational force, we have to take celestial bodies. That example, it is given here. Now, one question is asking in our mind. What? Now, whenever, sir, you have told that force between any two bodies are constant and that force depends on the product of masses and the inversely proportional to the square of distances, and the force is same for two different bodies, and here one story is coming. Assume here it is earth whose mass is m e. Okay, it is another body which is coming downward. Okay, which is coming from a height, its mass is small m, and assume if this distance, means whenever we have to find the distance, will go from the center of the earth, so this distance is r. Okay, so the force of attraction, that is F, is equals to g m e into small m by r square. Now you might be asking, sir, what is the problem with that? One problem is, just now I have told that each of the body here, if I am taking it is body number 2 and here it is body number 1, that how much force is applied by 1 to 2. So 1 will apply attraction force and that force is F to 1, that is force on 2 due to 1, and 2 is applying a force towards it, that is F12, and this 2 is equal, okay, and that is equals to GME into small m by r square. What I want to say? Yes, I want to say that force between any two bodies, that means if an apple is falling from a tree, that how much force is applied by earth to the apple towards its center, the apple is also applies same amount of force to the earth towards it. Then what is the problem? Then problem is why the apple is coming to the earth, why the earth is not going to the apple. If it occurs, then it will be very much interesting for us. Assume you are jumping from a height, instead of you going downward, earth is coming towards you, because as per the thing we have discussed, that forces between two bodies are same, then earth may also come towards me. Why I am going towards earth? Okay, it is very insulting. Why earth is not coming? Here, one problem is there. What? As the forces are same between two bodies, but we know from Newton's second law of motion that force equals to mass into acceleration, right? Force equals to mass into acceleration. So as the force is same, so we can write mass of earth into acceleration of earth should be equal to mass of the body, that is small m I have taken, into acceleration of the body, because as the force is same. Okay, so if I have taken only the magnitude, okay, we are not taking minus or plus. If the force is same, so mass of earth into acceleration of earth is equals to mass of body into acceleration of body. And from here, if I want to find the acceleration of earth, you see, m into a by m. So this m, you all know, it is very large. It is very large. And that's why if the denominator is very large, so we can say that the acceleration, this A means acceleration of earth, it is negligible. It is negligible. Okay, so that's why whatever we have thought that there is no motion is shown in the earth, it is not properly correct. Okay, there is also an acceleration comes to the earth, but it is so less because the mass of earth is very large. So we can conclude that as the mass of earth is more, so acceleration of earth is less. And for this the body comes towards earth, but the earth doesn't move. For that reason only, any body is falling downward, that is coming towards the earth, rather earth is not going towards it. It is the simple reason. More mass, less acceleration. Less mass or smaller mass, more acceleration, because from here we can say small a equals to me into ae by small m, and where me is very greater than small m, that's why this acceleration is very much, that's why the body comes downward but the earth doesn't go upward. Okay, I think the doubt is been cleared. Okay, now I'm telling you one smaller thing, and from that we will coming to the ending. The smaller thing is, when we are talking about the gravitational force of Earth, that is given a new name, that is gravity. So what is gravity? If we have told what is gravity, gravity is nothing but the gravitational force of Earth. That means when we are finding the force of attraction between any two bodies, that is gravitational force. And in between the two bodies, if any body is Earth, then it is known as gravity. So any object around the Earth that is attracted by Earth due to its gravity. So gravity is the gravitational force which is shown in Earth. Okay, so that is a smaller thing I just want to share. And the last thing we will discuss, that is a falling body. And for that we have to know, that is acceleration due to gravity. What is it? Assume sometimes we have played this thing, and this is very much common for us, that sometimes it has happened now, we have thrown a ball upward, and after a certain height the ball is coming downward, and that time we just want to catch it. Okay, so whenever it is coming from much height, then it is difficult to catch the ball, because that time the speed of the ball is maximum. And if it is coming from less height, then we can easily catch the ball. Assume you have thrown a ball from a height of 13th floor. Then the person who is standing extremely at ground floor, whenever he has catch the ball, it is little bit of difficult for him to catch. But if you throw it from 5th floor or 4th floor, then it is easier to catch. So here we have seen, more the height, more the velocity. Why? What is the reason behind it? Now whenever the body comes downward towards the earth, simply a force of gravity is acting on it. Force of gravity means the gravitational force by earth that is acting on the body. And we know what we know. See the concept, step by step concept you have to understand. We know that force equals to mass into acceleration. We know that from the second law of motion. So whatever I have discussed, the video has paused, that's why I'm just going there. Simple thing, as we know, force equals to mass into acceleration. So as the ball is coming from much height, then it is much in exposure of force of gravity, and that's why its speed will be increased. And if it is coming from a less height, okay, that time the exposure in force of gravity will less there, and that's why the acceleration will be less. So simple thing, whatever we have seen, that due to the force of gravity, the velocity, the rate of change of velocity is more for a falling body. Okay, so due to the force of gravity, the rate of change of velocity is more for a falling body. And that rate of change of velocity is acceleration. And that acceleration is known as acceleration due to gravity. Now, what is that? Now, what acceleration comes to a body due to gravity is known as acceleration due to gravity. Very simple thing. Don't think it very hard. That as the force is applied on a body which is coming downward, the force of gravity is acting on it, and due to that it will get some acceleration. Okay, because as the force is applied on a body, it will get acceleration. And as the force is constant, which is given by Earth, so that's why the acceleration is also constant, and that is known as acceleration due to gravity. Okay, and acceleration due to gravity, it is denoted by small g. So small g is acceleration due to gravity. We denote acceleration due to gravity by small g. What is its value? The value of small g is 9.8 meter per second square, or nearly we can take it 10 meter per second square. Okay, so in some numerical it is given 9.8, in some numerical it is given 10. So what is given to the numerical, based on that we have to do this. Okay, so what is g? G is acceleration due to gravity which comes to a body due to the force of gravitation by Earth on a body. Okay, I think it is clear. Now the question has come, how we can able to find this acceleration. How we can able to find the acceleration, that is calculation of acceleration due to gravity. How do we get it? We know that if one body is kept on the surface of Earth, so assume it's the surface of Earth, one body is kept over here. Okay. So there will be a force applied on the body by Earth. Okay, so assume its mass is small m, and here the mass of the Earth, you have to always remember that it should be concentrated at its center. Why? That you will know at class 11. Okay, so now you have to take this, that mass of Earth, it is concentrated at its center, and this is the radius of the Earth, which we have taken capital R. Okay, so the gravitational force between them, that is F G, how much? Now it is G M E into small m by R square. Simple thing. The product of two masses and the square of the distance, that is the gravitational force between them. Again, one thing we know. What is that? We know that whenever an object is at the surface of the Earth, it will feel a force downward, and that force is the weight of the body. What is the weight of the body? Now, from the very junior class, we know that weight is equals to mass into gravitational acceleration. Why I am writing it directly? I'm taking you more deeper. We know that force equals to mass into acceleration. What is weight? Weight is nothing but a force is giving by Earth to the body. So weight is a force. So it should be mass into acceleration. What acceleration it will be? It will be acceleration due to gravity. So mg is nothing but ma. Okay, so w is equals to mg. And as we know that force of attraction due to gravitation and weight, it is same. Okay, so this and this, these are same. So we can write as these two are same. So Fg equals to W. Fg means force of gravity. So what is the value of Fg? That is G me into small m by r square is equals to small m into g. And here you see this small m and small m, it will be cancelled out. And the value of small g is equals to g into me by r square. That is the gravitational acceleration of Earth. That means if I know the value of mass of Earth and the radius, then I can able to find the g, small g. So this small g and capital G, it is not same. You see, small g, it is gravitational acceleration, and capital G, it is universal gravitational constant. Two things are here. So small g equals to capital G into me by r square. And if we have put the value of me and r, we know that me is equals to 6 into 10 to the power 24 kg, and r, that is 6 into 10 to the power I think it is 4 square 6 kg. If you put the value here, the g will come, that is 9.8 meter per second square. I'm sorry, it is meter. 9.8 meter per second square. Clear? So that will be the acceleration due to gravity. And now one thing we have to mention. What is that? When we are talking about acceleration due to gravity, then one thing I will tell, that the shape of the earth, it is not spherical. The shape of the earth, it is told that it is earth-like shape. So it is very unique. So here we know that north and south, it is little bit of squeezed, and east and west, it is little bit of flatter. So whenever we are talking about radius, the radius of the earth, it is not constant. Whenever we are talking about the radius of the earth in equator zone, if it is told by RE, and radius along pole, these two are completely different. It is clearly shown that RE is greater than RP, right? So RE is the radius in equator zone, RP is the radius in polar zone, that is the poles. So here the gravitational acceleration in equator, so that should be G into ME by RE square. Okay, and mass of the earth, that cannot be changed. Mass of the earth, that should remain same anywhere you have taken. And gravitational acceleration at pole, that is G into me by rp square. You see, the value of gravitational acceleration in equator and value of gravitational acceleration in pole, these two are not same. Okay, clearly gravitational acceleration is in equator, it is less than gravitational acceleration in pole, because rp is lesser, so the denominator is lesser here, and here the denominator is more, so gravitational acceleration will be less. It is told sometime that if you approach from equator to pole, what you will feel? If we approach from equator to pole, we feel that the gravitational acceleration is increased. So gravitational acceleration in equator, it is less compared to gravitational acceleration in pole, right? So by this equation, we can able to understand this thing. I think this portion is clear. If it is not clear, then see it several times. I think you can able to understand. Now whatever I have told, that what is the difference between small g and capital G? Here we have seen now two G's are there. Two G's. One, it is small g, and another one, it is capital G. So small g, it is nothing but gravitational acceleration, and capital G, it is universal gravitational constant. Number two, small g, it can be, or it is changed for different place, and here we have to see it is constant. Okay, so these two are very important difference between small g and capital G. First of all, small g, it is gravitational acceleration which is coming due to the force of gravity by earth. Universal gravitational constant, it is capital G, okay, which is taking as a proportionality constant to find the gravitational force. It is changed, small g we have seen, it is in equator, in pole, it is changed due to the change of radius, because the shape of the earth is not a complete sphere. And here for case of capital G, we know that the value of capital G is never changed, okay, and that should remain constant. Clear? I think it is clear. Now we are coming to almost our ending part. Now you might be thinking, sir, from the first you are telling that we will coming to the ending part, but the video is increasing because I just want to give more and more information here. Because if you see in your book, it is only 3-page topic, but here whenever we have to discuss, we need to learn more, because this thing will be repeated in class 11 again, so your base should be clear. Okay. Now we are coming to freely falling body. Freely falling body means when a body is coming downward from a height. Okay. That is known as freely falling body, and we assume that here no other opposition force is acting on the body. The body is coming downward, and if I just want to find the motion of the body, then how can we able to do it? For that we need some equation. What is it? Let's see. For a freely falling body, when it is come vertically downward, clearly if any certain point, if we assume the velocity is u, when it comes downward, okay, it come more downward, the velocity will be increased, okay, due to the gravitational acceleration g, which is also acting downward. We have seen that gravitational acceleration is coming due to what? Due to the force of gravity. Okay, so it is also acting downward. So that's why vertically downward motion, if we have seen for a falling body, we have to use three equations. What are the three equations? That is the equation of motion, because they are also coming in a straight line. So the equation of motion will be v equals to u plus gt, h equals to ut plus half gt square, and v square equals to u square plus 2gh. Now if you see the equation, you might be thinking, sir, this type of equation we have done earlier. Yes, you have done. Whatever you have written a, okay, you have learned v equals to u plus at. So instead of a, I have just taken g, okay, because here the acceleration is gravitational acceleration g, and distance that is covered by the body. Whenever we are talking about a falling body, you are covering height, so here distance is nothing but h, and that's why the equation is changed. V equals to u plus gt, h equals to ut plus half gt square, and v square equals to u square plus 2gh. So for a falling body, if I just want to find any of the quantity, we can able to use this equation. If I have thrown a body upward, assume here you have thrown a body upward. Okay, so for this case, it is known as vertically upward motion. Whatever we have seen earlier, it is vertically downward motion. The body is coming downward. Now assume you have thrown a ball at a height. What we have seen, the ball is going upward. At a certain point, the ball is static, and then it is coming downward. That thing we have seen now. Why the velocity of the ball is going to zero? Whenever you have thrown a thing, assume the cap I have thrown, after going a certain distance, it is coming downward. Why? Because as you have thrown, you have given a velocity to it. But when it reaches to the extreme point, as it approach more up, then its velocity decreases. Why? Because you see, the gravitational acceleration is acting downward, and you have thrown the body upward. That means opposite to acceleration due to gravity. Whatever the things you have thrown, that is moving opposite to the acceleration due to gravity, and for that reason only, as it moves upward, its velocity is decreased, so it is a retarded motion, because this acceleration is acting on it as a retardation, because the direction of motion and the direction of acceleration is exactly opposite to each other. The direction of motion and direction of acceleration is opposite to each other, and for that case, what equation we have to use? We have to use v equals to u minus gt. We use h equals to ut minus half gt square, and we have to use v square equals to u square minus 2gh. So everywhere we have to put a minus. Okay, and then our work is over. So it is clear, for vertically upward motion we have to take, it is an accelerated motion, and for vertically downward motion we have to take, it is retarded motion. Okay, and based on this, some numericals are also there. Okay, but that numericals we have to do little later. Okay, we will not much eager to do the numericals, that we will do, and that will give you another video. Now we have to see the last thing. So by telling last, the time is increased. Okay, but last thing is very easier, so that's why I will take that it is not a problem. The last thing we have to learn, that is mass and weight. I think you have learned it earlier also. What is mass? The mass is amount of substance in a body, and what is weight? That is force applied on mass, on a mass by earth. Okay, so mass is amount of substance, weight is force applied on the mass by earth. Mass is constant all the time, but weight, it is not constant, because weight is equals to, we all know, W equals to mg. So as g is changed, then W is changed. Okay, so we cannot say that weight is constant. So here weight is not constant. Number 3, its unit is SI unit is kg. Its SI unit is, as it is a force, it is Newton. Simple thing. Okay, so these we can say these are the differences of mass and weight. Okay, and apart from this, one very important thing we have to mention. So mass, it is a scalar quantity, and weight, it is a vector quantity. Okay. So we have learned about mass and weight also, as we have done it earlier, and along with we have defined the difference between mass and weight. Okay, these four differences are enough. I don't think more differences are there. If you read book, one more extra difference can be added, that it is measured by beam balance and it is measured by spring balance. So all that things, it is known by you. Earlier also you have known that. Now really we have come to the end of the video. Okay, and that end portion, I'm just telling only one thing and then the video will be over. That as we know, the SI unit of force is Newton. But apart from that also, as we have learned gravitation, so we can take gravitational unit also. So what is gravitational unit? A smaller thing, that when mass is directly converted into weight. Mass is directly converted into weight, right? If I am talking about a mass of 5 gram, so how much weight it is given? Now the weight should be 5 gram force, GF. Okay, or in some book it is written 5 grams weight, GWT. That means the force given by 5 gram mass, that is 5 gram force, the force given by, or the weight of 5 gram substance, that is 5 grams weight. That means we have directly converted mass into weight. Similarly, if our object's weight is 10 kg, so we can write how much weight or how much force it will given, 10 kgf. Okay, or 10 kg weight. This is this kgf, gf, gwt, kgwt, these are known as gravitational unit of force. Gravitational unit of force. Okay, as we know, W equals to mg, so we can write 1 kgf is equals to 1 kgf means the force given by 1 kg mass, that is 1 kg into 9.8 meter per second square, that is 9.8 Newton. Okay, so 1 kgf, it is equals to 9.8 Newton. 1 gf, okay, so 1 gf means 1 gram, and its gravitational acceleration, if we learn that, it will be 980 centimeter per second square, so it is 980 dyne. This is the relation of 1 kgf and gf with its SI and CGS unit. So one thing you have to mind, that it is not a SI unit or CGS unit. These all are gravitational unit. These all are gravitational unit. Actually, this is SI unit and CGS unit of force. So this is the relation. Directly we convert mass into weight. Okay, and that is known as gravitational unit of force. Okay, so this is your theory. Up to that, it is end. Okay, so gravitation is ended. Try to understand it. If you read it carefully, I think you will get it. Thank you.